Okay, so I hope everyone can hear all right. Hello to everybody that's in the room and hello to everybody who's joining us online. So this is actually the first time we've ever done a virtual company showroom in hybrid format. So it's just a company showroom. And today we're delighted to have representatives from ICIS, Neutron and Muon Source, which is based at the Rutherford Appleton Laboratory in Oxfordshire in the UK. And it's a world-leading centre for research in the physical and life sciences. It's owned and operated by the Science and Technology Facilities Council. So today we're delighted actually to have Dr. Sam Pittman, who is a design engineer at the ICIS Neutron and Muon Source. She designs and procures bespoke beamline components, for the ICIS accelerator network, and provides expertise in high voltage and RF. So Sam spent 5 years here at CERN, where she completed her PhD and senior research fellowship in the CLIC high gradient test program. Hello, welcome. So I'd like to say a big thank you, and I would like to hand over to you, Sam, and then we'll follow up with questions once you finish your presentation. So I should give you this. Thank you very much, and thank you for joining us.
Well, hello, everybody. Thank you for coming on this horrible rainy day. It's really super raining here, so people have, there's some people who have cycled here, so thank you for that. Yeah, I'm Sam Pittman. Thank you for the introduction. I did start my career here at CERN. I did my PhD, as was mentioned, and my fellowship here. And then when I left CERN, I went to go and work in the medical industry, making accelerators for radiotherapy. I loved industry, and it was a completely different challenge. But while I was there, I really missed CERN, and I really missed big accelerator facilities, big science, you know, national labs. It's a different energy, a different feel at those places. So I went back to ICIS because ICIS is a national lab. It's run by the British government science body. So yeah, that's what I'm going to talk to you about today. Because when I was at CERN, I didn't really know what ICIS was. So it'd be good to just raise the profile a little bit so that you're aware of the facility and can consider it maybe in the future for any onward choices after CERN. Yeah, ICIS is based here at the Rutherford Appleton Laboratory. It's just south of Oxford. There's a few different big research facilities on the campus, also funded by STFC. We've got RAL Space over here. That's a space program. They, you know, do antennas and satellites, space research with the European Space Agency. There's the Diamond Light Source, that big synchrotron. You might think that's what I'm talking about today, but it's not. That's just another particle accelerator on the campus. That's for X-rays. We've got the CLF, the Central Laser Facility. They've got some big, powerful lasers that they do research with there. But what I'm talking to you about today is the ICIS Neutron and Muon Source. It's this bunch of buildings at the bottom here. Yeah. So ICIS, as I've mentioned before, it's a neutron and muon source. Here at CERN, you want collisions, you know, produce accelerators, and the main aim is high energy physics. But our goal is to produce neutrons and muons to be used to investigate materials, investigate matter, and it's a source for users. So people, you know, scientists come from all over the world to use the facility. So why would we image with neutrons? There's just a small diagram here where the size of these spheres, they represent how much it interacts with matter, and X-rays interact with electrons, so it sort of increases with the atomic mass. But neutrons, they interact with the nucleus. So you can see that for some different materials, different elements, it might be more beneficial to use neutrons, and you might get different information out. So they can be used complementary, but yeah, but that's what we're in it for. That's what our accelerators are for producing neutrons. Yeah, like I said before, people come from all over the world, thousands of people to use our facility for their individual research. We've got 29 neutron instruments and 5 muon instruments, and we squeeze about 1,000 experiments in a year, outputting around 600 journal publications. So we're really active, really outputting a load of good science at ICIS. Yeah, and it's not just people from all over the world that come to use the facility, but also we employ people from all over the world. You can see we employ people from every continent, and the mix of sorts of people that we do employ is very similar to here at CERN. You know, we've got lots of engineering, technicians, computing, and scientists, with a little sprinkling safety and health physics to make sure it doesn't all go wrong. So if your speciality is mentioned here, then this should be a really interesting talk for you. ISIS was really the first big particle accelerator driven neutron source. There aren't that many. There aren't as many as particle accelerators. There's loads of them all over the world. There's even 2 on our campus, but neutron sources are a little bit more rare. You can see them on this map. And we've got really heavy collaborations with all of them, healthy collaborations with all of them. So one of the things that drew me to ISIS personally was its collaboration with other laboratories. Like, it really feels like part of the wider particle accelerator community. So yeah, if that appeals to you, and if that's what you love about CERN, then we have that at ISIS too. So this is our facility. There's a sort of schematic here placed over a bird's eye view of the buildings. You can see we start with a H- ion source here up at the top of the campus in this building. That's the low energy section, and it gets accelerated through a low energy LINAC section, at what point it's injected into a synchrotron. At that point, it's stripped of 2 electrons. We're left with protons. And we accelerate those protons up to 800 MeV in the synchrotron, and then we kick out those protons to these 2 long beamlines. And the beamlines, contain everything you'd expect: dipole magnets and focusing and beam transport stuff, diagnostics. And then the protons hit targets here at target station 1 and target station 2. When the protons hit the targets, we make neutrons through spallation. Neutrons spray out in all different directions. And they get fed into all of these experiments. You can see all of these instruments all crowded around the target stations, and that's where all these different scientists are doing completely different things with the neutrons. And also we've got a little muon target here. There's an intermediate target, and there's 5 muon beamlines that come off of here as well. And then people are doing their muon research also. So in a bit more detail, this is that LINAC section, that low energy LINAC section that I spoke about earlier. We've got the H- ion source. It's a penning source. It then gets injected into this gorgeous RFQ. I'm obsessed with like machined copper. I think it's so beautiful. These undulating veins that focus and accelerate the low energy ions. It then gets injected into these drift tube LINACs. We've got these big drift tube LINACs, 4 of them. And yeah, I think it's up to 70 MeV. And then it gets injected into the synchrotron. As I said before, it goes through a stripping foil, these H- ions, and they lose 2 electrons in that stripping foil. And we're left with protons to accelerate around the synchrotron. Our synchrotron contains all the bits you'd normally see in a synchrotron, dipole magnets, quadrupoles, diagnostics, all the vacuum systems, stuff you may be familiar with. Of course, RF cavities, cannot forget the cavities. Yeah, and it's a rapid cycling synchrotron. So all the cavities and the magnets, they go through their whole range of operations at 50 hertz, 50 times a second. And yeah, the protons are accelerated to 80% of the speed of light in the synchrotron, at which point they're output to the targets. So I mentioned before target station 1 and target station 2. They sort of look like this. They're big blocks of metal, really. Some people say just a beam dump, but that's not fair. They're much more complicated than that. Really complex bits of kit. So you've got this solid lump of tungsten here. The protons come at it from this direction. And surrounding it, we've got these sort of hollow boxes, and they contain moderators, either water, hydrogen, or methane. And the purpose of that is to sort of slow the neutrons down, moderate the energy so that they're useful for the experiments where they're going to be used. After this point, it hits this beryllium reflector. This sort of comes around and encases the target in operation. It's all open now. This is how it would be maintained. But in operation, it's closed. And the purpose of the beryllium reflectors is to sort of guide the neutrons down to their instruments where they're going to be used by the scientists to perform the science. So yeah, really complex engineering challenges in something like this, like the heat loads and the radiation. Like a lot of the work on this is done remotely with like remote handling stuff. And yeah, like all of the sensors, the temperature sensors, the water, there's loads going on, really complex engineering challenges in this group. Yeah, the target stations look like this in operation. You never get to see the target as you did previously on the previous slide, because it's absolutely caked in all of this shielding. So it's very deep within here. And on this picture in TS1, it's somewhere in here. And it's caked in so much shielding because we just walk around this when the beam is on. You can walk around this whole area, and this is where all the magic happens. In these coloured block houses around the target, you can see there's like different experiments in each one of those. In target station 1, you see these sort of cabins, and each one is filled with like a lab. It will be for like cryogenics or an electronics lab or something like that, where people are doing all the preparation on their samples when the beam is running and in between beam runs to get ready for the next run and to get their data. Yeah, so all those instruments, they're so varied. There's no way I could talk about them all today. Here's 4 examples. This on the top left here is an instrument that looks at exotic magnetic phenomena. On the right here, there's the IMAT instrument. This is a neutron imaging facility where it takes really beautiful, clear, crisp images of whatever it is you're trying to look at. I did have a QR code on here, but it's disappeared. But in the freebies that we're giving out today, it'll be there, and it'll be on the one that we share with you later. There's a video on YouTube called Cold Snap. It's really cool. It talks about this instrument in more detail, and it shows you, it images a dilution refrigeration system, and you can see like the helium-3 and 4 isotopes separated. It's super cool. So check that out. This is one of the muon instruments. This is the Argus instrument. And on the right, this is an instrument that's used for a lot of cultural heritage studies. That's a 3,000-year-old sword in there. So there's the ISIS member of staff facilitating a visiting scientist. This is a visiting scientist from Iran who's come to find out more about this 3,000-year-old sword. So that's the sort of thing that goes on in these instruments. So it's really, really varied because each scientist is coming to look at something different, really varied work. Yeah, so we've just had ISIS-2 like design phases funded. We're designing the future accelerator. I mentioned earlier that ISIS was the first big particle accelerator-driven neutron machine, and that means it's really old, and so it's, you know, due an upgrade. And we've been funded for ISIS-2, and it's a mega exciting time to join because we're doing all the research studies now, you know, physics design, small scale prototypes. If you join ISIS now, you can really impact what happens in this future accelerator. It doesn't happen very often that we design a whole new facility and get to build it. So yeah, so it's a really exciting time to join and get involved in really sort of big work packages. So some of the opportunities that we've got opportunities in our low energy beams section. This QR code here, if you can scan it, there's a really exciting senior iron source physicist role going. This low energy beams part of the machine is due to be upgraded over the next 5 years from a penning to an RF iron source. We've got these really cool test benches set up, like little sort of beam lines that are independent ones, freestanding ones that don't impact the user machine. So you can be really daring and try the more risky things that you want to try in your research on those without affecting the users. Yeah, so exciting opportunities there. Of course, we've got an accelerator physics group. They take ownership of the LINAC and the synchrotron, those transfer lines. They do, you know, beam commissioning and machine physics studies, developing models and machine supervision. They do 24-hour operational support of the machine. We have on-call. Yeah, so lots of accelerator physics opportunities. Of course, like any accelerator, we've got tons and tons of beam diagnostics, around 250 diagnostic devices across the accelerator. And these are always being, you know, upgraded and improved and new ones designed because people always want more and faster, and you know how it is. So if beam diagnostics is your thing, then give that a look. Of course, we've got a radio frequency group. They deal with the RF for the LINAC, the synchrotron, all the high power RF, solid state amplifiers, tetrodes, triodes, but also low level, if you have any experience in that, high voltage power supplies. Yeah, this group gets to do a really broad range of work. The drift tube LINACs I showed you earlier, we recently upgraded one of them. I told you they're super old. So we got one made completely from scratch, and they got to assemble the whole thing on site. This is a picture of the test area where they'd assembled it and were testing it before putting it into the ISIS machine. We have a big design engineering group. This is where I sit. Actually, I work in the particle accelerator design division. The accelerators deal with the magnets, the cavities, the diagnostics. And then we've got a completely separate group for targets because they've got really, niche skills to deal with these high heat loads and all of the things that go along with targets. And then we've got a separate group for instruments, and they design and build all of the instruments that sit around the target, which again is very varied engineering, very varied challenges. And there's this Endeavour project we have going on at the moment that is to design 10 new instruments for the beam lines. So this QR code here has some opportunities in these design groups. If you're a design engineer, check it out. So we have, of course, electrical engineering, split roughly into DC, AC, and pulse power supplies. It's really varied again. So everything from like small motion control all the way up to like RF and like large power distribution networks. Of course, project management and procurement of like bespoke, power supplies and things that are unique to us. We're always looking for sustainable alternatives. Obviously, there's a big opportunity to reduce our consumption in a group like this, but our commitment to sustainability does extend everywhere. It's in everything we do at ISIS. We've literally changed how we govern projects to make sure that sustainability is always at the forefront of what we're doing. Like, how can we improve this project to make it more sustainable? So that isn't just lip service. It's really important to us at ISIS. Of course, we have control systems, and it's not just control of the accelerator, but the target stations, the instruments, all of these, individual things we've got going on. I think we're upgrading to Epics right now. So if you have any experience in that, and yeah, more machine learning applications. I know that's a bit of a buzzword, but I'm going to throw it in there. If you're interested in machine learning, we're looking at how we can utilize that to improve our control. And yeah, this is the perfect slide for this building, the full stack web apps, because we're in the data center here today. And yeah, I'm hoping that we can interest some people who are good at coding. The full stack web apps group do more of the like user authentication software, authorization services, beamline access requests, scheduling, like all that sort of thing. We develop all of that ourselves at ISIS. So yeah, if you're good at any of that, front or back end, we've got a really exciting opportunity, if you scan the QR code, for a senior management role in this full stack web apps group right now. The scientific software group is slightly different. It's closer to the scientists. So it's actually dealing with the data that comes out of the experiments and making it useful. So I saw on the front of this building today, as I was walking here, it says turning data into knowledge, which is what they do in this group. So data reduction and, development of the software that actually makes the scientists who come to do the research able to view it and gain knowledge from it. So if you're really interested in the application side of accelerators, then this is a really great group to work in. And here's just some examples of the work that they've done. This is for some strain experiment, and this is a neutron tomography, like 3D visualization tool that was developed. Yeah, really varied applications for computing at ISIS. Aha. Don't just take it from me. There's other people who work at ISIS, and they would like to tell you about their experience.
I'm the group leader for scientific software and ISIS, and we kind of look after all the software development for the facility to do with the experimental data and analysis and converting it to something that scientists can use. So the thing I enjoy most about that is it kind of feels like you're close to science and you're actually making an impact on you know what the users can do with the data, and you feel like you're all part of that research process. So it's really quite nice.
So here at ISIS we have a very dynamic work, which means that 1 week I can be working on operations and next week I'm working on theory. So every week is very different from the other. So I've been here for about a year and a half, and ISIS, as soon as I arrived, it seems to me like a very progressive and forward-thinking environment. So it's really nice to work in an environment where most people are actively trying to improve things.
If I want to get involved in training, learning new things, the answer is always, yeah, go for it. As long as it fits into your schedule, we'll make the time for it, we'll make budget available for it to develop you as a good engineer.
It's been really good working here because compared to my previous roles in the private sector, I feel like I've been able to progress quite quickly. And that's been because ISIS and the SDFCs provided quite a lot of training. They do provide a lot of training. There's a huge focus on training within the organization, which is great if you take advantage of it. And it just allows you, people give you chances all the time. It allows you to progress very quickly.
Since I have arrived, I've been given a lot more responsibility than I have in the past, and that has given me a lot of opportunity to learn, to grow, and to develop.
I found that career progression has been really good here. So when I wanted to move forward in my career, I found that line management is really great for working with me on identifying areas of weakness, making sure that the opportunities are there so I can develop myself in those areas so that the doors can sort of naturally open to progress. They're always really supportive in making sure that we've got all the boxes ticked to make sure that you're ready to go on the next level if that's what you want.
Management encourages good boundaries between work and life. We have good flexible hours, so if people need to leave to collect their children, etc., from school, that's a very common thing. And we also have a good balance of working from home and working in a lab.
A huge benefit for me is the flexible working system that we've got here. So not just the flexibility in the hours that I work, but also the flexi leave. So as a new father, being able to vary my hours to fit around my family life is really important. And the fact that I can build up extra hours and then take on extra flexi leave on top of my annual leave means that I get to be around to see all those key milestones of my son as he's been developing. And that's been really fantastic for me, and I made a huge difference in this first year of his life.
Yeah, so, oh, I'm on mute. Yeah, so that person, John Speed, with the high vis on there, he's actually my manager. And since this, he's been promoted again since he made this video, and he's now group leader. So it really is being invested in. Back to the talk. So yeah, it's true what they say about the training as well. I mean, I don't think I've ever felt as invested in as at this place. I think I've been on 2 CERN accelerator schools and like 3 conferences in the past year at ISIS. So yeah, they really are developing their staff. These are a load of vacancies that we've got at the moment and upcoming vacancies. The QR code will take you to the place where you can get all the details and apply. We also have these talent pools where you can just submit your, your profile, your CV, and then if an opportunity comes up in that area, then we can contact you. In that video, it was mentioned a lot about the flexible working and the work-life balance. Like, that's really true. The campus being such a large campus, it does have loads of stuff going on. I do boot camp 3 times a week, and that really helps with my, exercise and mental health. There's, I think, a rounders tournament every year, and touch rugby and football, and there's just loads and loads of stuff going on that makes the workday a bit more interesting. 40.5 days leave is massive anyway, and then with flexi, if you use it right, you can add an extra 26 days off a year with that. So really loads and loads of leave, enhanced maternity leave, of course, cycle to work scheme. The campus itself is very accessible, very easy to access. There's lots of free car parking and buses, and it's accessible. additional benefits, like one of the main benefits to point out at CERN, where people struggle between, you know, temporary contracts, trying to string them all together and plan their life. You get open-ended contracts at ISIS, so you can get, you know, a permanent position and really sort of have that stability. That's a real benefit. An amazing pension scheme. Employee recognition seems cool. Like, I randomly just got a couple of £100 the other day just because I did a good job on something, and someone recommended me for the prize. So yeah, there's lots of recognition. There's a relocation allowance if you are moving from another country or even somewhere else within the country. On-call and shift work, you know, that's compensated. And we've got, you know, lots of immigration support. You'll be sponsored with your visa or whatever it is that you need to come and work in the UK. We're a very inclusive employer. Eliminating discrimination is really important to us. And, you know, this isn't just lip service. Again, I think if you do have a disability, you automatically get an interview at ISIS, and you'll be provided with accommodation, like suitable accommodation for yourself, if you meet the minimum requirements of the role. So yeah, we're aiming to be a really fair, you know, and inclusive place to work. And again, it's not just me. These are some of the results I picked out from the People Survey. This is an anonymous survey done, not with your manager stood behind you looking at your answers, and people's responses are amazing. People are genuinely really happy at ISIS. Like, it's a great place to work. People feel seen, people love their work, you know, it's a really happy, good vibes lab. Yeah, so there's some FAQs on the screen here. Feel free to read them or to ask me a question in real time. I hope this has been informative to you. Yeah, if you are ever considering your next steps on from CERN, then please do consider ISIS. It's a fantastic place to work. Thank you. Yeah.
Thank you. Actually, no, you keep it, and then well, we can use the microphone here. So thank you so much, Sam, for that, and also nice to see you make an appearance in the video as well, Haroon. We now are coming to the part where we have our questions. So I wonder if there's any questions on the chat, or maybe some people in the room here have some questions.
One, but I don't want to take away this thing. Okay. So for me, my experience is I've not kind of progressed in the speed that normally you'd expect people to progress in the scientific environment. I've just finished my master's degree a year ago, and I'm now 29. So I have a fairly wide gamut of like things I can do. So I'm pretty comfortable with a scope in an electronics lab. That's where I currently work. I'm perfectly happy writing GPU optimized software, which is what I do in my free time, all the way to I have some experience with RF and what's the name, software-defined radios and antennas and what have you. But I don't have this typical, you did your bachelor's, you did in 3 years, you did your master's in 2 years, you did your PhD in 3 years. So I don't know, I'm 25 and I've got my PhD, I'm looking for a postdoc. That's not my story. So it feels like very much that, you know, I look at this and you're looking for senior engineers and stuff, and I've looked around and lots of the time it feels very intimidating to me, because it's like, you need to have your PhD, you need to have the thing. It's like, well, you know, I've ended up not doing my PhD. I tried, it didn't really fit what I ended up wanting to do. So I moved away from this for now. And that's kind of where I'm like, is there a role in there as well for people that don't follow the very typical kind of, you know, bachelor, master, PhD, postdoc kind of?
Can I take this question actually? At ISIS, there's a really broad range of people from different backgrounds. So we have an apprenticeship scheme. So some people come through that route where they do the apprenticeship and then they work their way up from there. Or then you have people like me that did a more academic route. I started at CERN, I did my PhD. We have grad students that go to university, do their degree, and then come and do the grad scheme. We have people from like lots of different routes up to where they are, and it doesn't impede your progression at ISIS. There's somebody in my group that's at the same level as me, and he came through the apprenticeship scheme. He's a completely different engineer, and we work fantastically together because he's really practical and he's way better at like the more physical manufacture side of things, and then I'm more theoretical and more academic in that way. And all of these different backgrounds really make an amazing team. So that will definitely be appreciated at ISIS. And I think it says in all of our job adverts actually that it's like PhD or relevant experience. It's on you actually to come to the interview and show your experience and show them what it is you can do.
What kind of like experience is also like I've noticed at CERN they say like relevant experience is 2 years at a job, and I'm like, well, you know, okay, 2 years at a job can be relevant experience, but I do a lot of the stuff that I've learned through just like playing around with.
I would say what you've done is what matters, and you can show that. You know, you can show that in a presentation. Usually, you do a presentation at a job interview, but your CV, like you can do it. You can show what you can do, and that's what's important, I think. For
the like, I am British, but my current girlfriend is not British. She's from India, and so like visa stuff for like people that would be like, does this need to be like legally married in that sense, or can like is there a?
I guess Chelsea is online.
I think dependents
might be able to answer that question. But before she does, I will just quickly say that now that we're hiring people, it's very important to consider the attitude of the hiring managers and what they are looking for. And what we look for are people who want to do the job. So I think as long as you can convey that, then that's generally more important than whether or not you've done a thing.
Okay.
Right. If you are willing to learn the thing, then we will teach you how to do the thing.
Yeah.
Oh, that sounds very nice.
Right. So as long as you want to do that job, then that's what we're looking for. So over to Chelsea, if she could answer that one.
Yeah, so thank you very much. And hi, I work in recruitment, part of the HR team, and look after STFC ISIS. So with regards to the roles, etc., as mentioned before, we try and cut out all things that are to do with time. So relevant experience is down to kind of the managers, as they've said, of what you can present. But relevant experience is always put on all our adverts. So it's for you to just showcase those and put them on your cover letter and CVs. It's not always that we need things like PhDs or a certain amount of time in this industry or that industry. We try and cut all of that out to be inclusive and be more towards the ED&I sections. With regards to visas, obviously immigration is a minefield. So I'm not an expert in the immigration field, but if it's to relate to you are from a certain country and you want to live in England and you need a visa, we cover all of those aspects and the dependents. If it's to do with that you have the right to work to come to England, but your dependent doesn't, that would be something that we need to look in case by case, because that's a little bit of a different situation than what we normally had. But again, immigration is not my forte, but we do cover certain aspects, so it's not a hard no. There's just things that we have to look at case by case.
I can say from experience that UKRI and SDFC are willing to cover large amounts of money to cover visa fees, and also to guide you through all of the processes to make it easy.
Yeah, we have a dedicated immigration team that work alongside our recruitment team and the employer or the person that's being employed. And they pretty much handhold all the way through and do the application with you. So yeah, very inclusive on those sorts of things.
Thanks.
Okay, is it okay if we go to a question in the chat? So from Giordano, he was wondering, how do you handle your procurement processes? Is there any procurement rep in ISIS, or is it managed somewhere outside the organization?
Yeah, that's a complicated question, actually. It's through UKRI. Like the UKRI is like the funding body from the government that then funds all of the different, I think it's 9 different councils. So it depends on what you're buying and the amount and things like that. You know, that there's different routes to procurement, whether it's going to a large tender or through single source action. Like there are different ways to procure things. Don't know if you have a specific question about something you want to procure. Anyone else comment on that? I think it probably covered it.
You answered it, yeah, really. Okay. Do we have any questions? Any more questions? Yeah.
On the RF side, does the ISIS source and like the Diamond Light source, do they have like their own simulation teams, or is this like, do they commit to like larger simulation software, or do they run their own stuff? Or
we have a bunch of software. Like it depends on who comes, and what I would say is, if you have a particular flavor of simulation software that you like, then you'll be able to get a license for it. You know, the normal CST, Opera, like things that you'd see here. Yeah. not a dedicated team as much. Like a lot of the simulation stuff will be done like in the design team. Mark, I can see Mark Keelan's online. I don't know if you do simulations in your group.
Good morning. Yeah, so think of the RF group, as I state, more as an operational support group. So we tend to look after the hardware, the running of the hardware and the maintenance of that. The simulation of the RF that we produce into the cavities tends to be more under our sort of beam physicists and machine physicists side of things. But yes, simulations are run as to how the cavities will react, how the amplifiers will feed those cavities, and what the beam dynamics ultimately results with in terms of an efficient machine. So yes, it's not one team, it's not one set of people, it's not one simple answer. It's spread across multiple people, and I guess we all have an input and a sort of guide to what we want to achieve with it.
So I can add another answer. Is basically depends on the project, depends on what you're working on, depends on the time scale. If you have the time, so the one thing that I really like at ISIS is that if you want to do a PhD, then we will support you, and you'll be quite lucky to do a PhD with Oxford. You'll be able to do it as a member of staff for 6 years. You're paid. We cover all your fees, and that really gives you the opportunity to dig deep and really focus on your PhD question. And it's usually something really with a lot of operational benefit or boon at the end. And if you want to spend those 6 years developing your code to do that, then that's fine. But if you would rather spend your 6 years running code that we pay for, then that's also fine.
In that regard, like I've recently-ish come about computational topology, which is like an interesting thing of like visualizing fairly high dimensional amounts of data. This is something, given the fact that you have like ancient swords and all kinds of interesting things that you shoot various neutrons and muons at. I'm assuming this is like fairly interesting to you as a group.
Super interesting.
Okay.
I think from what you've said already, you cover experience in many different groups, and the difficulty for you will be finding where you want to go.
Yeah, the groups are going to be fighting over your skill set, I think.
Anyway, yeah, thanks a lot.
Any more questions in the room? I had one, if I may. Yeah, I was wondering. So CERN is fairly international. How does it compare at ISIS? Is it as international as here, or do you have a majority of UK people? What's it like?
I think probably a majority of UK people, but it is very, very diverse. We have people from all over. I showed before the slide with the world map on. We've got people from all over, and every group has like someone from somewhere else. We are very. I wouldn't say it doesn't feel as international as CERN to me, because everybody's speaking French here, not English. But it is extremely diverse. Yeah.
I mean, I can add that a lot of the instrument scientists, they bring very specific expertise. So when you need that expertise, you have to look internationally, and you won't find that in the UK. So I think, maybe I could be wrong, I think the majority of our instrument scientists are non-UK. And then we have lots of users. So a great deal of our users are international. So like CERN, we have member states who contribute in kind, etc. The muon instruments, I think 2 or 3 of them are completely designed and operated by Riken, which is in Japan. So we have a large number of international visitors. And yeah, in that sense, we also have the users from Diamond. So the campus is definitely international. Sam mentioned the European Space Agency at the start. That is actually on our campus as well. So yeah, very diverse in that sense.
Okay. Thank you. Any more questions? Let's see. Sorry, go for it. Yeah.
Okay. My girlfriend currently does SciComm here at CERN. Do you have like open SciComm roles, interest in that kind of area, hiring there or not?
Science communication. I'm not aware of any. So I can definitely say that we have public engagement, is what we call it.
Yeah,
we have public engagement groups in every facility. So each facility, has its own. Okay, Steph.
Steph, you can take this question.
Yeah, well, I'm guessing you're talking about Chetna.
Yeah.
So I work for STFC, but I'm currently based at CERN, Steph Hills. But I'm part of the comms team for STFC. So yes, we do have a team. We have, as Sam and Harun said, we've got a public engagement team, but also a press team. So there are, from time to time, opportunities. I wouldn't say it's a huge team, But yes, we do have a comms team.
And then each facility has a few people that run their individual facility comms.
So we do lots of open days and tours and things like that. And that CORDSNAP video, you should watch it. It's super cool. That was a bit of science communication that we did with the dilution refrigeration. It has got like little Lego stop motion characters in it. It's cool. She'll like that.
Yep. The slides for this will be online because you flashed a bunch of QR codes. And
they're in your hand, in your USB stick as well.
In your hand.
Take one of those pens and you'll have the slides.
But yeah, will this be sent out? Right,
yes. Yeah. So just so that so everyone is aware, we will put the slides onto the alumni.cern platform. So where the event is, and then also if you go and look at the event itself, you'll see that there's a link to the job opportunities that have been posted. And we regularly get postings put on the jobs board on alumni.cern. So don't hesitate to pick them up there. Any more questions? There was a question that I was going to ask, and that was, so do I understand correctly that it's not like at CERN where you come for a 5-year contract? Once you are employed as a staff member, you are then, you have a
open-ended is the way,
okay.
It's what it's called. Most of the, I think all of the ones were advertising are open-ended contracts. And also one of them I wanted to mention, because I know this appeals a lot to people now, the software senior software manager role is either completely remote or in the office or hybrid. So there's also like a lot of flexibility depending on the role. If you're operational RF, you're probably not going to be able to work from home, but you know, there's a lot of flexibility with that as well.
So if you're completely remote, does that mean you can be completely remote in a different country?
I don't know the ins and outs of that regarding like the rules and like tax and stuff. I bet like the government have something to say about that, but I'm not sure about that, to be honest.
I can comment from a colleague who's in scientific computing who is based in Manchester full time, but then they have a few times a year they all come on site and have like a week together and do activities and fun things together, which is nice.
You're going to want to be on the campus though. Like we're having a Great British Bake Off thing. Like there's just loads of fun stuff happening on site that you're going to want to be a part of. So.
And you said all the sports activities, and things like that. Yeah,
there's too much. Like I don't have enough time to do all of the sports that I want to do.
Yeah,
I mean, it's a supportive environment. While I was here at CERN, I was lucky enough to be part of the basketball club, as you know, Rachel, and we started to petition the DG for a hoop on site.
At CERN?
Yeah, at CERN.
It's still ongoing.
I know it's still ongoing, right? That was 6 years ago. It's still ongoing. At ISIS, or rather at REL, I sent an email, and within a week, they bought 2 professional basketball hoops and a bunch of basketballs and allocated time and space on the tennis courts, which is also part of the campus. And that was all free.
Okay, great. Which makes me think you should come and take part in the Atomiad.
Yeah, I would like to.
We'll talk about that later. Yeah. Yes, please go ahead. Yeah.
It's about the seniority. So in ISIS, there is the opportunity to redirect your career. So imagine somebody with many years of postdoc that just want to work on something else, because here at CERN it's penalized. And but yeah, in a sense that you cannot take certain contract if you have already some sort of level.
Yes, I know this actually. If you have certain experience behind you, you're not applicable to certain roles. Yeah, I can't see that happening at ISIS, to be honest.
No,
can anyone comment on that?
I can tell you that you have to consider ISIS is one of the facilities of the SDFC, of which there are many, and SDFC is one of the councils of UKRI, of which there are many. So I can quite easily hop to another research council in another role, pretty much like this if I want to. So there's lots of internal roles and people do this. So we have different sites. So an accelerator physicist from Daresbury Lab might decide to want to come and live in Oxfordshire. And so that they can, you know, if there's something open, they can switch to a role. I mean, it's not like so simple, but there are people that do this all the time. So we get people coming and going from Diamond and ISIS. And, you know, that's one way you can climb the ladder. Some people prefer to stay in their own group and stay focused on their own expertise and climb the ladder that way. But yeah, there's definitely a lot of routes to progression, and there's no obligation for anyone to progress or to do something different.
also I would add to that I took quite a career change in my job at ISIS. I looked at the advert a million times and I was like, I only meet like one of the things on there, of the bullet points of competencies or experience. And I thought I just put it off for ages. And then in the end, I just thought I'll just apply, show them what I can do, and they can decide if I'm useful to them or not. And it was a bit of a left turn in my career, and they were completely supportive and open with it. And it made me nervous as well when I was there. I thought, oh no, like my experience isn't 100% like fitting in this group, but I was so supported to learn the things, the gaps in my knowledge, and to fill them in training courses and stuff. So I would say that it would work for you as well. Yeah. Thank you.
We saw that Callum, who was online, had his hand up. Callum, would you like to come on cam and please ask your question?
Yeah, can you hear me?
Yes, great.
Great. I had a question actually about just talent pools for say like there's currently not a vacancy that's open that you'd be interested in. Do you have open talent pools where you can just send sort of your CV and covering letters?
So I can step in on this one. So yeah, we definitely do. So we have our careers email, which I can put in the chat. And what you generally do is just put the details that you have and maybe your CV, and we can put you into the talent pool so that if a job does come up, we can obviously send you an email to keep there. Obviously as well, we do have our LinkedIn pages as well, where we do post a lot of things and a lot of projects. So that's really good to keep an eye on as well, of what's coming up.
Okay.
And as we've said, the careers portal here with the QR code, just keep looking at that as well. But definitely I'll just put it in the chat now, our careers inbox, and that's where you'd send your information and we can put you in the talent pool.
Perfect, thank you.
Great. Any more questions in the room? Now's your perfect opportunity. You have two alumni here.
Then I'll just go ahead and ask the questions. We're fine. So this is a mostly UK funded lab, right? We're not talking 50% outside UK funding. We're talking 10 or something.
I think the laboratory is UK funded, but then there's different contributions made to the instruments, usually in terms of expertise and hardware. And like I said, I'm an accelerator physicist, and obviously I love CERN because these are the most complex machines that humans have ever built, as far as we're aware. And they work, right? They work, and it's incredible. But each of those neutron instruments are, they have the same level of complexity as an entire accelerator. So interesting stuff.
But then the funding for like paying staff, that's all UK.
Yeah, government pension, all the same. Yeah. I think the exception would be the users, right?
Yeah, no, that's kind of the same here, I guess. Okay.
Do you usually find that people will do their whole career at ISIS, or do you find that there's? I know you said that there was a bit of churn between the different labs, but
yeah, we have a lot of people. My boss has been at ISIS for 30 plus years, and then his boss has been here a few more years. And to be honest, the only reason we don't have people who've been around for 40 years is because they've all retired. And then my boss will retire in a few years. So yeah.
It's really varied. We do a lot of training. As we've mentioned, we get a lot of grads, and so you get some that will stay and take the opportunities on site to develop, and then you'll get people that come to CERN or go to other labs and like go off and come back, and yeah, there's lots of movement, but there's also lots of people that do their whole career there. Yeah.
Okay, interesting to know.
The housing situation in and around Oxfordshire, how does that look like? Because like in France, like Saint-Genis is surprisingly expensive for what it is. I'm assuming having like Oxford University not too far away and itself being a fairly large lab, I guess that
it really depends where you pick to live. It's a bit like here in that sense. If you live in the centre of Geneva, you're paying different to Saint-Genis or Ferney, and it's a bit like that. You've got sort of Didcot and surrounding areas around the lab. Yeah, it's a personal choice. I would say that you know, all rentals, I guess, are quite expensive, and Oxford is an expensive area in the UK. But my encouragement to you would be to just have a look at the, you know, the wages on the jobs, and have a look at the local area and work it out for yourself. But
to add to that, I think what really helps is the flexible working hours. So flexibility can really help you there. And a lot of people live surprisingly far from ISIS just because they can, and they want to live on the coast, or they want to live close to their partner's work, or, you know, that gives them the flexibility to do that. And the cool thing about working at Rutherford is that it's basically on the edge of an area of national beauty, or outstanding national beauty, whatever they call it, a nature reserve, which is all forests, and, you know, it's a nice place to live.
And then a synchrotron.
Yeah. But yeah, I mean, that's part of the design consideration. I think we had to build a big mound to cover the synchrotron, so that the view from the ridgeway is still impeccable.
It's part of the ISIS 2 work as well, making sure we don't spoil the view.
So yeah, there are benefits. I mean, you have to pay for those, of course, but you have the option to live a bit further away, and then it's cheaper.
Any more questions here or questions in the chat? No, I think we've got someone who, no. I thought perhaps there was a hand that had gone up. Well, so just to remind everybody who's watching and also who's here today, the slides will be put on alumni.cern. The recording will also put on once you've looked at it and you agree to us posting it on the platform. I guess that if people want to contact you, they can contact you on alumni.cern, because you both have your accounts there.
On that, or on LinkedIn. I'm on LinkedIn as well. Reach out, however.
Great. And we've got the details here, and also I saw that Chelsea, I think, has shared the link in the chat. So if we have no more questions or online, all that remains to be said is a huge thank you to you so much. Thank you so much, Sam, for coming and giving this great presentation. I don't know about you, but I think it looks like a great place to work. Do they have an alumni program there?
We are thinking about starting one, actually. We've been inspired. Yeah.
And so thank you so much. Thank you also for joining us online. Thank you, Chelsea, Mark, and all the other colleagues that joined us.